Hi, my name is Keegan.
And I'm Kevin.
We are both juniors here at Westminster College in Salt Lake City, Utah.
Do you like having class on Fridays? Nah, me neither.
Most classes at Westminster don't have class on Fridays.
Do you like to ski and snowboard?
We do, and there are 6 convenient ski resorts within 30 minutes of campus.
Ayo! Do you like psychology? Well, we've got some pretty sweet psychology professors here.
If you enjoy any or all of these aspects, Westminster is probably a good fit for you.
Come to Westminster! Speaking of psychology, we're here to tell you about the importance of our field. We will inform you about research designs and the importance of research in psychology. The main points we will be talking about are correlational designs and experimental designs. We will also be talking about variables, cause and effect, and we're going to drop some knowledge on your noggins about predictions and how they differ from experimental and correlational designs.
First, we need to establish some baseline definitions to further understand future topics. What are variables? Variables are elements that can change and vary. Examples of variables are memories, amount of stress, performance, reaction times, etc. Later in this video, we will talk about different types of variables that are used in different types of research designs.
Experimental designs allow us to see the directionality of relationships between variables. Experiments are used to determine cause and effect. So what does this all mean? Well, first, let's address some important rules that must be followed to make a proper experiment. A true experiment needs to be in a controlled environment with a control and treatment group. This means that scientists must create a situation where everyone will be treated the same with the exception of one variable. This is the independent variable and will be applied to the treatment group only. The experimenters will then observe the effects of the independent variable, also known as the treatment, on the other variable in the experiment, the dependent variable.
The control will not receive the treatment, and this is important because then we can assume causality between the independent variable and the dependent variable if the effect occurs in the treatment group and not in the control group. Lastly, and very importantly, participants must be randomly assigned to either the control group or the treatment group, and the participants should randomly be selected from the entire population. It is important to note, however, that often it is impossible for experimenters to control for all variables, confounding variables, and to have a truly random sample of the population. Thus, the experiment will also include limitations in their study's findings.
An example of an experiment would be testing whether people who drank alcohol will have slower reaction times compared to those of a control group. In this situation, drinking is the independent variable and reaction times is the dependent variable. Imagine that the experiment showed that people who drank had slower reaction times compared to people in the control group who were not inhibited by the effects of alcohol.
Another important type of variable to consider is a confounding variable. This is when a researcher doesn't control for a variable which has an influence on the results. Say you're trying to determine if eating more calorie causes weight gain. A possible confounding variable in this experiment would be the amount of exercise a person gets. Confounding variables are a large limitation with both correlational and experimental research. Correlations are important because they allow us to measure variables which cannot be controlled for either ethical reasons, such as post-traumatic stress or human malnutrition, i.e. we can't starve people, or for logistical reasons, such as sex or age. We can't change someone's age. Correlations, when used properly, can provide ideas of interesting areas to conduct experiments. Correlation allows us to see a connection between 2 or more variables, but they cannot establish a cause and effect relationship. This can only be done with experiments. Positive correlations are when one variable increases, the other one will increase. A negative correlation is as one variable increases, the other one will decrease, and vice versa. And no correlation is there's no connection between the variables.
An everyday example of a correlational study would be height and weight. This has a positive correlation, which means that often as people get taller, they also tend to weigh more. However, it is important to note that this does not mean that everyone who is taller will weigh more, and everyone who weighs less will be shorter. A correlational study merely predicts a relationship between 2 variables.
Overall, research designs are important for the field of psychology to either predict a cause and effect relationship or a causal relationship. So, the main takeaways of this are correlations predict relationships without directionality.
Experiments predict cause and effect relationships, and always think about possible confounding variables.
And remember,
correlation does not infer causation. Ayo!